Good day, everyone. I am Dr. K. Vijay from the Department of Civil Engineering. Today, we will be exploring the fundamentals and applied aspects of surveying in our session titled Exploring Angles, Distance, and Curves. We will delve into the precision of the theodolite surveying, the efficiency of tachometric methods, and the geometric of setting out curves, which will all critical for infrastructure development. Thank you for your presence. Uh, to navigate through today's extensive topics, we will first cover theodolite surveying, the cornerstone of angular measurement. We will then explore tachometric surveying, a rapid method for determining distance and elevation. This will include a look at both the stadia and tangential methods. Next, we will discuss the trigonometrical leveling for the height determination. Finally, we will apply these principles to curve surveying, examining the types of curves and the methods used to set them out in the field. Let us begin with the workhorse of traditional surveying, the theodolite. It is a precision optical instrument designed for measuring horizontal and vertical angles with the high degree of accuracy. Its applications are vast, including traversing, triangulation, and differential leveling, and the setting out of curves. Modern iteration have evolved from vernier and optical theodolite to fully electronic or digital theodolites, which offer digital readouts and improved efficiency. It's called the temporary adjustment. Uh, To ensure accurate measurement, a theodolite must be properly set up. This involves four temporary adjustments that are performed at every instrument station. First, setting up, mounting the instruments on a tripod and leveling it roughly. Second, centering, precisely positioning the instruments directly over the survey station, mark using a plumb bob or optical plummet. Third, leveling, making the vertical axis truly vertical using the foot screws and plate label bubbles. And fourth, focusing, eliminating parallax error by carefully focusing on the eyepieces of the optical lens. One of the most powerful application of the theodolite is to determine the height and the distance indirectly by measuring vertical angles and the known baseline distance. We can use trigonometrical principle, a process known as trigonometrical leveling, to calculate the height of inaccessible objects like towers, chimneys, or mountain peaks, which are invaluable in engineering projects. Permanent adjustment beyond the temporary adjustment, perfectly daily, a theodolite requires permanent adjustment or calibration to ensure its fundamental axis maintain their correct geometric relationship. This including ensures the axis of the plate level in perpendicular to the vertical axis. The line of sight is perpendicular to the horizontal axis. The horizontal axis is perpendicular to the vertical axis, and finally, that the line of collimation coincides with the optical axis of the telescope. These are crucial for the instrument's long-term accuracy. Measurement of theodolite using the repetition method, one of the standard method for measuring horizontal angles with high precision in the repetition method. The process is meticulous. After setting up and performing temporary adjustment, we will on face left. We sight the first point with the vernier set at 0. We then sight at the second point and read the angle. Without changing the initial setting, we lose the lower clamp, swing the instruments back to the first position, and then sight the second point again. This repetition of the measurements allows errors to be averaged out, significantly enhancing the accuracy of the final angle. This slide outlines a procedural method for the closed traverse or for closing the horizons. Yeah, techniques to measure all angles around a point to check for observational error. The steps involve setting up the station, sighting a series of stations in sequence PQRS, on recording the angles. This process is then repeated on the face right to eliminate instrumental error. Any misclosure error is then calculated and adjusted to distribute it across all measured angles, ensures the sum of the angles around the point is perfectly 360 degrees, which gives us the reliable final results. Next one is the tachometric surveying. Now let us move to the rapid and efficient method that eliminates the slow process of direct chaining or taping. It is used as tachometer, which is essentially a theodolite fitted with a special stadia diaphragm to determine horizontal distance and elevation of a point indirectly. This makes it exceptionally useful in rough wooded, or otherwise inaccessible terrains where conventional methods are impracticable. Uh, this primary objective of the tachometry are threefolds. First, to measure the horizontal distance between the points without physically measuring them. Second, to determine the reduced level. The principles of tachometry is based on the geometric of similar triangle. The tachometry study of diaphragms have two additional horizontal hairs. The central crosshair, by reducing the interval on the graduated staff between these two stadia hairs, we can compute the distance from the instruments to the staff reading using a fixed formula known as the stadia formula, D equal to Ks plus C. So where K is the multiplying constant and S is the staff intercept and C is the additive constant. Um, some applications of the tachometry, the principles of tachometry are extensively in civil engineering. It is dispensable of topographic survey to create contour maps of hilly areas. There are various methods. There are two main methods of tachometry. The first and most common is stadia method, which itself has two variant. The fixed hair method, where the stadia hairs are fixed, which itself has two variant. Fixed hair method, where um, and the movable hair method. The second main method is the tangential method, where instead of stadia hairs, two precise vertical angles to a staff are measured to compute the distance and difference in elevations. Trigonometrical leveling. Closely, this method of vertical angles measurement from the theodolite combined with the measurement or calculated horizontal distance to determine the difference in elevations between 2 points. Transition from the measurement to applications, we arrive at curve settings in transportation engineering. A curve is a smoothly flow arc and of constant and varying radius used to connect it to the straight line alignment known as tangents. The primary purpose of the curves is to provide a smooth transition for vehicles, ensuring safety and comfort by providing about changes in directions. There are various types of curves: a simple curve, compound curve, reverse curve, and the transition curves. Setting out of curves on the ground requires precise method. Common techniques includes a tangent method or method of deflection angle, which is very accurate or commonly used by the theory. The chart method using successive chart length. Other method involving calculating offset from chart, produced or offset from tangents. Rankine methods of tangential angles is another popular techniques that uses deflection angle to locate point on the curves. There are various applications of curve. The applications of curves is fundamental in infrastructures in highway and railway. These are essential for aligning routes smoothly through changing topography. In canal or pipeline, gentle curves are used to maintain the efficient flow to avoid pressure loss. In urban roads, these are all the limitations. Despite the utility, the methods we discussed have limitations: the instrumental limitations, the environmental limitations, design limitations, and operational limitations. Has the This process is obtaining the time consumptions and requires a skilled survey. Errors by easily creep into the proper, improper, and instruments using setup the by sighting. Further environmental limitations such as obstructions, tree buildings, and adverse weathering, fog, heat waves that can be hampered by surveying works from the design perspectives. Um, this brings us to the conclusions of our exploration into the angles, distance, and the curves. This principle forms the bedrock or precise measurement and designing the civil engineering project. Thank you for your engaged participation. I have happy to address any questions you have. You can contact me, Vijay Sulwe at ksrcity.ac.in. Thank you.